Now, guys, we're starting chapter 4. Chapter 4 is going to talk about congruent triangles, but we're going to start talking about congruent figures, congruent polygons uh, from this point, and then do specifics about congruent triangles. First off, what makes figures congruent? They have to be alike in every way. They're exact images of one another. Okay, these two polygons are congruent. That means everything from one is the same as the other. Angle for angle, side for side. So all corresponding sides are congruent. That is, you see side ED and its congruent side, its corresponding side, E prime D prime. Okay, you're going to see that they are of the same length. Okay, you're going to see that angle A here is the same as its counterpart up here, angle A, which is not there, but angle A is the same angle. Okay, so there's the angle measure showing that they're alike. So in order to be congruent, they are alike in every way, angle for angle, side for side. Okay, you can't have a hexagon being congruent to a pentagon because they're not having the same side. So obviously they have to be the same type of figure. Then they're alike in every way when all the angles match up, all the corresponding angles, and all the corresponding sides. And we're going to illustrate some of these things using Sketchpad in class. So stay tuned for that. So as far as we know here, all corresponding sides are congruent, all corresponding angles are congruent. If all these things are true, all the corresponding sides, all the corresponding angles, then the polygons are said to be congruent. And there's something in the way in which we say it here. So it, the polygon ABCD is congruent. Here's our congruent symbol, the equal sign with the little wave over top, and it's congruent to A prime, B prime, C prime, D prime, which means side AB matches up with side A prime, B prime. Okay, side CD matches up with side C prime, D prime. So all the corresponding sides, C and C prime angles match up. So just in this arrangement here tells you which sides are congruent, which angles are congruent. Now, there's a couple different ways of getting congruent polygons, and whether triangles or whatever polygons, there's the slide, okay, which we'll illustrate with Sketchpad, okay. Regardless, the polygons, the triangles ABC and DEF are congruent, the congruent symbol, meaning AB side is congruent to the DE side, okay. BC side is congruent, okay. It looks like I should have labeled that a little bit better, and we'll show you that momentarily. But this is the slide. So I'm sliding along a line from B to D. The one polygon slides to the other, okay? That's a translation, okay? That's a translation or a slide. All right, now we're back, okay? Now we have congruence by rotation. So the pink polygon has been rotated 90 degrees around this point E to this location, okay? And they're congruent by a rotation. They're congruent by a rotation. Again, look for the sides that match up. Look for the angles that match up, okay? You're going to have a 90 degree, a 30 degree, whatever angle of rotation you want. Again, uh, that will be illustrated in Sketchpad. There's a flip, okay? Here's two, these are convex polygons, right? Convex polygons. Obviously, they look alike, and they are mirror images of each other across this line EF, across this mirror line EF. So that's a congruence by reflection, congruence by reflection. Again, which angles match up? D and D, B and B, just by virtue of their position. We know just by virtue of the position. A has got to match up with, okay, what should be over here is A, which is what you would get when you flip, okay? So A is going to A prime, C is going to C prime, okay? Because of the flip, it's not a slide, okay? Like we saw in earlier ones, okay? Um, so we have to say these two triangles are congruent if they are alike in every way, which means effectively you have to show that there's 6 parts of one are equal to the 6 parts of the other. That is, all three sides and their corresponding sides are congruent in all three angles. So you have to name, okay? You can see, you should be able to see which angles are going to match up, okay? And that's how you're going to match it. You can see the single curls are going to match up, okay? That's B with Y. The double curls at A and X, and the triple curls at C and Z, okay? So if these two triangles, and this is where you have to watch the order. If I say A, B, C, I got to find what's matching up with A. It's X. It's X, Y, Z. Okay, so you just don't randomly put them down there. So those are congruent if they're alike in every way. That is, A and X are matched up as congruent angles. B and Y are matched up as congruent angles. And C and Z are matched up as congruent and equal angles. And the corresponding sides. AB, okay, with its corresponding side XY, BC with its corresponding side YZ, and AC with its corresponding side XZ, okay? Uh, we will find that in this chapter there will be postulates which will uh, not require us to show that there are all 6 parts of one triangle congruent to the corresponding 6 parts of another. We'll reduce that to 3 parts in various combinations, okay, with a couple different uh, proofs and theorems, okay? And they are the side, side, side. We're actually going to get to this in the next presentation, but it's right here and now, okay? So there's the side, 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 the side angle side, and the angle side angle. So there's going to be 3 things. This combination of all 3 sides of one are congruent to corresponding sides of another, then you have triangle congruence. Okay, if if 2 sides and the angle in between, that's why it says SAS, are congruent, then okay, um, uh, then the 2 triangles are congruent. Or if 2 angles in the side in between of one are congruent to the 2 angles in the side in between of another triangle, they're congruent. We will again demonstrate these with some sketchpad activities. Okay, so we'll come back to that in the next presentation. So that is all for now.